So, a few students are experiencing issues compiling their work for questions 2 and 3 of the assignment. They're using VS Code and getting errors about packages and classes not being found and stuff. So if you're experiencing those issues, this little demo is for you. I'm going to give a quick crash course on the command line and give you some quick advice that should resolve your problem. The thing that's causing your error is the fact that you have multiple classes that have the same name. Java sees A3Q2/inventory and A3Q3/inventory and gets really mad. So the solution to that is to just open up each questions folder completely separately. And then that fixes it. The thing with making a launch.json file and then pressing the play button should work, but I also want to show you how the markers are going to be executing it, because in these sorts of assignments, you should try to make your setup as close to the markers setup as possible. So I've got A3Q2 open. Actually, I'm going to open up A3Q3 just to demonstrate how you open up a specific folder in VS Code. I want to try to assume as little as possible about your setup, other than the fact that you're running VS Code. So go to File. It's going to be at the top left of your screen on Mac, top left of your window on Windows and Linux. Open folder. And then you might have to do some file system navigating. Luckily, I'm already here. I'm going to choose A3Q3, open. Oh, and I already have the launch.json file from the last demo, but we're actually going to ignore that. Pressing play here should work, but I want to show you how to do it on the command line. To run your Java program, it's going to be 2 separate steps. First, you're going to compile your code into bytecode, and then you're going to run the bytecode. To compile it, you use, oh wait, I skipped a step. To open the terminal, you go to View, Terminal. So then, as planned, to compile your Java code, you say Java C, and then the name of the Java file that you're going to run, the one with the static void main string args, whatever. Ignore the rest of the line. That's a bit of an optimization. Press Enter. It'll take a little while. It'll take a much longer while the first time you do it, but it'll compile. It'll create a bunch of .class files. And then to run it, Java test inventory. So this will run, but complain about assertions. So to fix that, you can, wait, is this even visible? If it wasn't, hopefully this is better. You would use this command instead, but I'm lazy. Typing is hard, so I'll show you a trick on the command line. You can press the up arrow to get to the last command that you used. And you can do this repeatedly to go through your history. So I just pressed up to get the last command, and I'm going to add -EA to it. Oh, and it's telling me I should also add G. I'm going to do that. And there you have it. This is how the markers are going to be running your code, and how I recommend you run your code too. the main takeaway of this demo is that if you're having issues with packages, go to File, Open Folder, and open each question separately. So, oh yeah.
What's the launch JSON for?
Launch.json is for if you're launching it through VS Code. Like, I think if you have the right extensions installed, there will be a play button up here. Otherwise, there's a play button here. Launch.json is for configuring what happens when you press that play button. The command line is completely separate. It doesn't look at launch.json. I'll give a few moments for any more questions. After that, we'll talk more about 2-3 trees. Last class, we did a demo of a bunch of insert operations on a 2-3 tree. The items were all inserted in ascending order, which would have resulted in a horrifically unbalanced binary search tree, one that just goes like 1, 2, 4. What was the next one? 11? And then any operation on it to search or delete something, insert something new, would have taken linear time, would have gone through all of the nodes in the tree. And that's bad. The 2-3 tree and its fancy definitions and algorithms made it so the tree stays balanced, and thus searching for an item or inserting or deleting or whatever will take big O of log n steps, as you only have to traverse one branch of the tree, which, as we showed on Monday or Wednesday or something, excuse me, as we showed on Monday or Wednesday, don't remember exactly when, the length of a path from the root to a leaf has big O of log n edges in it. So if you're implementing a 2-3 tree, which may or may not happen on the next assignment, no guarantees, you'll of course need to have a node class, and programming it might get a bit weird because, oh, this isn't a good example. This isn't either. This is an okay example. Actually, I'm going to go with this. Because nodes can have some very different configurations. You can have 1 value and 2 children, 0 children and 1 value, or 2 values and 3 children, and also 2 values and 0 children. On top of that, there's this intermediate state that occurs during an insertion where a node has 3 values and up to 4 children. So that's basically 4 states that you have to worry about, 2 of which should only be, wait, 2 of which the nodes should only be in that state for a small amount of time. And there are a few different ways to go about this. The simplest and perhaps most effective way is to just have 2 value fields. So like you would have private int value 1, private int value 2, and 3 children fields, private int, or private node left child, middle child, and right child. And then some of those would be null and others would have specific values depending on the situation. Like I said, that's the simplest way you could do it, and most of the time, the simpler the better. Easier to maintain, easier to understand. But you might want to use a slightly fancier solution in order to avoid these states getting mixed up. If you have just those two data fields and 3 reference fields, you could get into a situation where you have an invalid configuration, like 2 values and 2 children, or 1 value and 1 child. And that could lead to some errors that are perhaps hard to spot and definitely mess up your algorithms. So maybe you can make 2 different classes for a node with 1 item and 0 or 2 children, and another class for a node with 2 items and 0 or 3 children. And then another class for this, I guess. And then you would use inheritance and polymorphism, all the cool stuff you touched upon in 1020, but we'll learn more about in 2150, assuming you're a comp sci student. I don't know what engineers do. Use inheritance and polymorphism to make it so those node classes can coexist on a tree. That would be hard to understand, but more resistant to bugs. Pick your poison. In this exercise, we want to find a number such that inserting that number into the tree causes the height of the tree to increase. And drawing the result, you should do on your own, but I don't have the time or the space for that. So let's see. To increase the height of the tree, we're going to need to make a node on the bottom level expand. Actually, anything on the second highest level should expand. And we can do that by inserting a value that's between 2 and 8. This will cause a value to be in between them in this node. Actually, first it would cause a value to be put in its middle child, but then that will set off a recursive node expansion, and then we'll still be good. So we're going to put a number between 2 and 8 into the tree. It's going to land here. And then this node will have 3 values. That'll be illegal. I'm going to say it has 4, 5, and x. X will be moved up here. This node will have 2, 8, and x. And of course, the same thing that happened on the 4 and 5 node will happen again. Whatever is the middle number of these 3 will go up. Without loss of generality, assume that it's still x. And then that'll cause the root to have 3 values. So its middle value will go up. There will be a node with 11 as its left child, node with 22 as its right child. It'll have a node with the smallest of the 3 values as a left child and a node with the largest of the 3 values as a right child. You know what's going on. I think the slide says 6, so we're going to go with that. But of course, any number that would be inserted into the leaf containing 4 and 5 would work. what numbers would be inserted into the leaf containing 4 and 5? Anything between 2 and 8. So 6 is inserted into the leaf after 4 and 5. A good name for nodes that have 3 values in them in a 2-3 tree is an overfull node. So we end up with an overfull leaf. We push up the value 5 because it's in the middle, and we end up with the node above it having 3 values and 4 children, an overfull internal node. So 5 will be pushed up. 2 will be 5's left child and will have children 1 and 4. 8 will be 5's right child and will have children 6 and 10. Like that. And pushing the middle value of those 3, 5, up to the root causes the root to be overfull. So the same thing happens. We push the middle value 11 up. Its left child is 5, which will have children 2 and 8. Right child will be 22 with children 18 and 26. Yippee! This is a high quality quiz question. Next week's quiz is probably going to be identical to this one, except with 2-3 trees. Actually, I take that back because the delete operation is horrendous, and I'm not sure if I'm mean enough to put that on the quiz. But there will definitely be something about inserting into 2-3 trees. I think I'm going to start on the delete operation, go through the easy cases today. We have 10 minutes left, so that'll probably take the rest of the class. But if we get into the hard stuff, I'm just going to leave that to next week. I'm okay to leave class early, or I'm okay to end class early because I want to give you all time to ask questions about the assignment. Anyway, the delete operation starts out simple enough. You search for the value to be deleted, and then if the value is in an interior node, swap it with its successor. And that way, you always start the delete operation on a leaf. So here's an easy deletion. Say we want to delete 19. The leaf node contains 19 and another value that we don't care about. So we just delete 19. We don't even have to worry about actually deleting any nodes, managing any references. We just make the node not contain that value anymore. This one's trickier. Now say we wanted to delete 21. If we deleted 21 first, it would be easy for the same reason as 19. But now 21 is alone, and we have to delete that entire node. In a binary tree, it would be okay to just delete that node, leave 18 without a right child, but that's actually not allowed in a 2-3 tree because, do I want to scroll up? I don't want to scroll up. It would violate the definition of a 2-3 tree. 2-3 trees have to be just right in order to maintain all these balancing properties. And so it's fussy about stuff like leaving gaps. Luckily, a sibling of 21 contains 2 values. So we're going to delete the 21 and then sort of just redistribute the values from the parent and sibling. You might be tempted to put 15 here, but that would violate the search tree property since 15 is less than 18. So we're actually going to move 18 here and 15 there. Neat, right? Here's another example of redistribution. We're going to delete 1. That would leave an unacceptable gap. 2-3 trees can't have any node with 2 values and 2 children, but one of its siblings has 2 values, so we can just delete the 1 and redistribute. So going from this configuration to the redistributed one, the lowest value will be here because we don't have a left child anymore. The lowest value is going to be the left value of the parent. So we put 2 here. And then we won't be able to stop here because the node now has 1 value and 3 children, violates the definition. So we need to take one of the values from the siblings and move it up. Since we're missing the smaller value of this node, we're going to use the smaller value from the sibling. And end up with something like this. Trickiest case. What do you do when you have a node with 1 value and you want to delete that value and its siblings also have 1 value? You need money quick and all your friends are broke. What do you do? We're going to leave that till next week. In the meantime, try and think about this, see if you can just figure out what should happen. But actually, don't do that. Focus on the assignment. And with that, good luck. Have a good weekend. Email me or go to my office hours if you have any last-minute questions. I'll be able to answer all questions given before 5 p.m.